So this is 12.5 part 2, and we're going to talk about a few properties of logarithms. We're going to have a few more in one of our next sections, but for right now, here are some properties of logs. So if b is a real number, that's the base, it's greater than 0 and not equal to 1, so that's always been the truth, then these three things are true. The log of any base of 1 will always be equal to 0. So if this value is a 1, your answer always has to be 0. And when you think about that, that's because if I change it to its related exponential, the only way I can get a 1 here would be to raise this number to the 0 power. Here's also a big one. The log base b of b to the x. So if this base, the base of the log, is the same as a base here being raised to an exponent, the answer is simply the exponent. Now the third one, you don't see very often, so quite honestly, I would just memorize it. You'll maybe see it twice. But again, it kind of follows what this one is. If the base and the base are the same number, then the answer is simply going to be x. So we have actually examples right down below of both of those. So look at this one. Simplify this. So the log base 3 of 3 to the second. So do you see where the base of the log is the same as the base being raised to the exponent? Your answer is simply 2. It is the exponent. For this one, see how the base of the exponent is the same as the base of the log? Those numbers are the same. Your answer is simply 3. And that is it. No work to be shown. But we're going to use this one when we do log equations in one of our next sections. This one you use a lot. Not so much for that one. All right. So let's look at how we're going to graph these log functions, and we're going to do 2 of them. So you can see here they have, oh, that's interesting. I didn't change this. So there's a little typo here. What you're going to want to do is you're going to want to change this to its related exponential. So the related exponential for this would be 3 to the y equals x. So this should be a 3 right here. So change that if you wouldn't mind. 3 to the y equals x. So now here's the deal. We are going to plug things in for y. We're going to plug things in for y. Oh, I'm not liking the way that this looks either. You know what? We're going to do a whole nother chart. Bear with me. I don't like the way this looks here. So we're going to make our own chart. And we're just going to do this. Just make an XY chart. Because really all you're doing is you're plugging values in for y. It would be really hard to plug values in here for x. You can't do that. Which is, I think, what this chart's trying to say. We got this from the book, but I think this says it a little bit better. So we're going to plug values in for y, and we're going to get x's. So for example, we could plug 0 in for y. What's 3 to the 0 power? That's 1. We could plug 1 in for y. Now notice my values. I'm putting them in the y column. 3 to the first is 3. Let's plug 2 in. Well, 3 squared is 9. Now if I plug 3 in, that's getting awfully big. That's 27. So we're going to go negative. Make sure you're plugging in negative values. What's 3 to the negative 1? That's 1/3. And how about 3 to the negative 2? If I plug in negative 2, that's going to be 1/9. So now these are the values that we are going to plot. So 1, 0, 3, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2 is going to be out there. 1/3 negative 1 and 1/9 negative 2. So look at this. We should recognize this as what a logarithmic function looks like. We graphed one earlier. You can see that it's asymptotic to the y-axis. It's going to get really, really close to the y-axis, but it's not going to touch it. So there's it's the graph of y equals log base 3 of x. That's what the graph looks like, but we changed it to its related exponential to help us plug in values. Okay, we're going to do the same thing here. We're going to change this to its related exponential, and then we're going to do an XY chart. So its related exponential is going to be 2 to the y power is equal to x plus 1. And then we're going to get the x alone. So it'd be x is equal to 2 to the y power minus 1. So here's the related exponential. And just like the above example, we're going to make an XY chart, but we're going to be plugging values in for y to get our x's. So let's go ahead. How about if we plug in 0 for y? Well, 2 to the 0 power is 1, and 1 minus 1 is 0. So this graph goes through the origin. Let's plug in 1 for y. 2 to the first is 2, minus 1 is 1. Let's plug in 2 for y. 2 squared is 4, minus 1 is 3. Let's plug in 3 for y. 2 cubed is 8, minus 1 is 7. All right, let's go negative. Always make sure you plug in negative values as well. If I plug in a negative 1, 2 to the negative 1 is 1/2, and 1/2 minus 1 is negative 1/2. Now you have a calculator to do that. Oops, let's plug in negative 2. If I plug in negative 2, 2 to the negative 2 power is 1/4 minus y is going to be negative 3/4. Oh, let's go plug in one more. How about plugging in negative 3? So 2 to the negative 3 is 1/8 minus 1 would be negative 7/8. All right, let's see what we got going on if we look at the graph. We should know kind of sort of what it looks like. So 0, 0, 1, 1, 1, 2, 3, 2, 7, 3 would be out there. So negative 1/2, negative 1, negative 3/4, negative 2, and negative 7/8, negative 3. So let's look and see what's happened. Do you see where the points are getting closer and closer to negative 1 as opposed to getting closer and closer to this axis, which means that this line right here, x equals negative 1, is actually your asymptote. So let's finish graphing, and then we're going to look at our equation again. So your graph looks something like this. Now, if you look back at our equation, do you see this x plus 1 in parentheses? Remember what that did when we did all of our other graphs, when we did quadratics, for example, was the big one. What happened if it was inside parentheses? This is a shift of 1 to the left. And of course, if this had been x minus 1, our graph would have been shifted 1 to the right. But because it shifted 1 to the left, our asymptote went from being the y-axis to actually x equals negative 1, this axis. Let's quick talk about the domain and the range for this. what would the domain of this function be? Well, where did the x's start? Do you see that the x's start right after this -1? So my domain would be all values from -1 to infinity. And what would my range be? Well, where did the y's start? The y's keep going down and down into -infinity, and they keep going up and up into +infinity. So my range is -infinity to +infinity. Let's just take a quick peek up here as well and do the domain and the range. This one didn't have the shift. So the domain, do you see the domain here would be from 0 to infinity? And your range would be from -infinity to +infinity. I go back up here and talk about that because remember, for exponential functions, your domain was all real numbers and your range was from 0 to infinity. So don't forget, when you're talking about inverse functions, which exponential functions and logarithmic functions are, your domain and your range has been flipped. And that's exactly what's happened.